Okay, we're going to be taking a look at the sequence and making sure we can use sequence notation to write the terms of sequences. Sequence, pretty simple, it's a list of numbers. Now the list of numbers might go on forever, in which case that's an infinite sequence. Or the list of numbers stops. You say, hey, it's a finite sequence. It didn't go on forever. First term is always going to be called A1. Second term is going to be called A2. Third term will be A3. The nth term, A sub n. So for example, that top sequence, A5 would be 13, because the fifth term in the sequence is 13. That middle sequence, A5 would be 48, because the fifth term in the sequence is 48. Of course, finding the expression for the nth term can be loads of fun. So if I plug in the number 1, how do I get 5? If I plug in the number 2, how do I get 7? If I plug in the number 3, how do I get 9? It looks like it's 2n plus 3. Right? 2 times 1 is 2, plus 3, I get 5. Let's try the second number. 2 times 2 is 4, plus 3 is 7. Yep, that worked. How about the third number? 2 times 3 is 6, plus 3 is 9. It works. Hmm, 3, 6, 12, 24. It looks like I start with 3, and then I keep doubling it, right? 3 times 2 is 6. 6 times 2 is 12. So we start with 3, and we multiply it by 2, but we do that n minus 1 times. So for example, if I want the a sub 4, right? If I want the fourth number, it better be 24. So I plug a 4 in for n. 4 take away 1 is 3. 2 to the third power is 8. 3 times 8, of course, is 24. Oh my goodness, look at these fractions. What on earth am I going to do? Convert them all to a common denominator. And now it's more clear that it keeps going up by 1/42. Well, Notice that alternates between positive and negative. Ooh, factorial.